So picking up where we left off, today we're going to be starting with some of the stuff with exponents here. So we'll be doing some where we have something written like this example here in yellow, and then we're converting it over like this. So let's see. So starting with number 16, they say to write the power in words and as a product. You don't actually have to write it in words. That's all it's wanting you to say is like with, well, we'll do it with this one. If you have this as your problem, what they're wanting you to write is 12 to the 5th power, but you don't just think about it in your head when you do it. You don't actually need to write that part. So how many 12s do I have? 5. So you're going to have, oh, and look, I wrote a 5. So you're going to have 12 times 12 times 12 times 12 times 12, and that's all you have to do for those ones. Let's see. 18, 3.2 raised to the 2. So what would I have here? 2 of them, so 3.2 times 3.2. So then seeing another one written a little bit different, 1/2 raised to the 8th. So we treat this the same way as we would any of the other ones. We're just going to write 1/2 8 times. So sometimes I question why they have to make you write so many. There we go. All right, and then one other way that you might see it would be like 22 y to the 6th. So I have 6 y's. So each of y times y times y times y times y times y. So those ones, they just wanted you to write out however many there were. The next section of the problems, it's going to actually want you to do the multiplication of how many there are. So when we had, like, I'll just use number 16, they would actually want you to multiply that out. Now, I'm not going to expect you to do that with, 12s. That's just obnoxious. I'm not even doing that. But we'll do a couple here. All right, so 26. So I have 3 raised to the 2. So written out, that's what? Yep, 3 times 3, which is what? Equal to what?
9.
Yep. So that's all you have to do for that. 28, we have 1 raised to the 5th power. So this one is a little bit interesting. We can still write it out as 1 times 1 times 1 times 1 times 1. But a little trick is 1 raised to any power is just equal to 1. So, which might kind of be common sense, but I've seen the mistake before where somebody actually writes some other number. And I'm like, no, you just multiply 1 times 1 times 1 times 1. Like, it's the same thing. So, let's see. 30. We have 5 raised to the 3rd power. So what would this be?
5 times 5 times 5.
Yep, 5 times 5 times 5. And then with this one, so what's 5 times 5?
25.
25. And then 25 is like what kind of money?
Quarter.
A quarter. So if I had then 5 quarters, how much money do I have?
125.
Yep, so then this one is equal to 125. So I like to give some fun ways for how to like remember things and how to do things and whatever. I mean, you also could, once you had the first one, you could also set up your multiplication like this if you wanted to, but I think it's cool to show you the different ways to think about it. All right, 32. We have 2 raised to the 6th power. So we have 2 times 2 times 2 times 2 times 2 times 2. So with this one, I would just work your way across. So what's 2 times 2?
4.
What's 4 times 2?
8.
What's 8 times 2? Yep, 16. What's 16 times 2?
32.
Yep, 32. And then what's 32 times 2?
62. 4.
64. 64. So with those ones, I always work my way across. I always start counting. I'm like, okay, I've gotten this many 2s. Okay, I need to keep going.
I'm just embarrassed to use my fingers for some reason.
With this stuff though, like it's just helping you keep track of how many, because like that's why like when I was just doing it, I was just moving my pencil along with it because I have it written out. But sometimes I'll be like sitting there and I'm like, oh, I don't feel like writing out 10 2s or something, so I just start using on my hand, figuring out how many I have.
I never used my hands actually. Like
I mean, when I was younger, like I would use them to like do my math, but like I'm right with this, it's like, oh, I'm just using them to count however many I'm at. Like, okay, I've done 2 of them, I need to do 3, 4, 5, 6 of them. So nothing wrong with that. I have nothing wrong with that. All right, so this next one's gonna be a little bit different. So it's gonna be how 20 was. Okay, so I'll show you how we're gonna think about this one. 34, we have 1/4 raised to the 2. Okay, so eventually I'll teach you some like shortcut rules to remember how to do exponents. Actually, that may not even be till much later, but for right now, we know the method of just writing the thing down that many times. So I'm going to write 1/4 2 times. And then when we multiply fractions, we multiply the top numbers times each other and then the bottom numbers times each other. So on the top, you have 1 times 1, which is 1. And then on the bottom, you have 4 times 4, which is
16.
16. So the answer is 1/16. Let's see, that looks good for that section. The next ones, let me see what's left. Okay. So this last little section here says to evaluate the expression. So it's kind of a combination of this first set of problems that we did where you were plugging the number in and this stuff. So you're plugging the number into something that has a power on it is basically what's happening. So 38, we have x squared when x equals 3/4. So we plug in the 3/4 to the x squared. So we replace x with 3/4. So we have 3/4. And I always like to put it in parentheses, especially when I'm dealing with the powers. Raised to the 2. So then I have, because it's raised to the 2, I have 3/4 times 3/4. So how would I go about solving that one? Or what would I get?
3 times 3 on the top.
which is what?
9.
And then on the bottom?
And then 4 times 4, which is 16.
Yep. Well, apparently that's the only one where it's like that. The next one's going to give you, instead of just one thing to plug in, it's going to give you 2 things to plug in. So with this one, it's x plus y when x equals 11 and y equals 6.4. So I'm going to replace x with 11 and y with 6.4. So I have 11 plus 6.4. And what would that be? So ignore the decimal. So what's 11 plus 6?
17.
17. And then since 11 doesn't have a decimal on it, we just add the 0.4 to the end. If it's easier to see it, you can write it stacked up like this so that you would just be able to add down. So we just keep the decimal points. They have to stay lined up with each other. But since there's not one on this one, that one just gets carried down by itself. All right, last one. 42 w minus z when w equals 9.5 and z equals 2.8. So I'm replacing w with 9.5 and z with 2.8. So I have 9.5 minus 2.8. So then with these ones, since they both have a decimal, I would say it's probably easier to write it stacked up like this to deal with, especially because it's subtraction. So I have 9.5 minus 2.8. So 8, there's not, words. 8 doesn't go into 5, so I'm going to have to take 1 away over here. So then that's going to be a 0.7. And then 8 minus 2 is going to be 6. So my answer will be 6.7. Any questions about any of those ones? Anything? All right, so what I'm going to do is I'm going to give you some to work on and try on your own. And then it is Wednesday, so if you don't finish them before class is over, which we have a decent amount of time, so you'll probably at least get most of them done. They won't be due till Friday, but if you want to go ahead and finish them tonight just to knock it out and get out of the way, that's completely fine too. So the problems are 3, 7, 9, 11, 17, 19, 21, and then let's see, 27, 31, 35, and then 39 and 41.